Good morning, I'm James. I lead the spatial data processing part of the SCRI project, the Efficient Vineyard project. And I'm at Cornell today. I'm here on a trip for the summer to talk to some of the growers and to interact with some of the other project partners. So I'm taking the opportunity today to do a quick podcast and to talk a little bit about some of the other processes and analyses that we've been doing while I've been in England, which is where I'm based. So I wanted to talk today about this little sensor again. So this is the NDVI sensor, is what everybody calls it. It's a crop circle. It's one of the numerous types of sensors, so there are lots of different marks. This one's made by Holland Scientific, but there are other options. The industry, growers, even researchers just refer to it as an NDVI sensor. So I wanted to dispel a couple of myths about that and to talk a little bit about how you can use the data out of here in other ways. So you can see here it's actually got three little filters. So there are three holes here. So this is a 3-band sensor. So what it's actually doing is measuring the reflectance. So the light comes out, reflects off something, and comes back and hits one of these filters. And one of these is red, the other is the red edge, and the other is the near infrared. So this is the part that these two, the red edge and the near infrared, we can't see. Obviously we can see red light. The NDVI uses these two and it's just sort of a ratio, okay? And that is really useful in trying to interpret where vigor is high and vigor is low. But we have 3 bands, so we can put these bands together in lots of different ways, okay? So we can have the top one divided by the bottom one divided by the top one, the middle one divided by the top one, etc., etc. Put all 3 together, sum them, divide them, multiply them. There's lots of different ways of combining those band data. But NDVI, which was developed in the 1970s from the first of these type of sensors, is the one that everybody uses. And it's a good one, but that doesn't mean it's the best one. So some of the work that we've been doing over the last few months is trying to evaluate, is there a better vegetative index, so a better way of joining these bands together to get more information, particularly about pruning weight in our vineyards. So we've been looking at about 20 different combinations of these bands, and what we find is if you use that middle one, the red edge, you get better results than if you use just the red and the near infrared. So as I said before, the NDVI actually just uses the red and the near infrared. It doesn't use the red edge. But the red edge bands, and they're often called chlorophyll bands because this red edge and the response in this red edge part of the spectrum relates more strongly to chlorophyll than the pure red and the near infrared. So we've been combining these together and looking at how they relate to the pruning weight data that we've had over the past few years. So it's quite interesting. It's not a big change. You know, we're improving our predictions by 3 to 5%. And it's a little bit different. If we actually look at some other more aggressive ways of compressing the data, we seem to be getting better results. So this is using very fancy statistics, such as principal component analyses, and we're just starting to look at those, and that seems to give an even better output and a better variable that we can use for predicting pruning weights. So hopefully we'll have that out and running and have some of this analysis for people to see very shortly. Oh, what do I see with these sensors in 5 years' time? I think 5 years ago I didn't think that I would see these sensors particularly used on UAV systems. I think we'll see a lot more of these sensors in UAV systems in vineyards. I think what we'll see is we won't just have 3 bands, we'll have 5 or 6 bands. And what we can use them for is we can say 2 of these bands and the relationships and the ratios or the indices that come out of those bands, 2 of these bands are good for early season. Some of them are good for yield prediction or crop estimation or using them to do crop estimation. Other combinations are much better for predicting pruning weight. So at the moment, everybody uses NDVI when they do their crop estimation. They use NDVI when they use their pruning weight estimations. But pruning weights and crops and yield estimations are 2 different things. So why are we using the same canopy response variable, i.e. NDVI, to do both of those? So I think you will see some differentiation and some movement away. And what we'll see in the future is that these are just filters, so you can put different filters in here without too much trouble. So as we get better at understanding which part of that spectrum relates best to pruning weight, shoot counts, cluster numbers, crop, then we'll start to have these systems built that are more specific and more targeted. I think they'll stay the same sort of size. For vineyards, you'll always have an opportunity to do this in the row as you drive down a vineyard on a tractor. As I said, I think the applications with UAV and scouting with UAVs will become much more prevalent, even in viticulture.